Good morning students and welcome back to chemistry class. Today we are going to discuss on the fourth step of extraction of metal ore, that is refining of metal. So the first step which we have learned is about the concentration of the ore. The second step was the conversion of the concentrated ore into oxide. The third step was the reduction of the oxide ore, and the fourth step is refining. Now the metal which is obtained in the third step after the reduction of the ore is still impure. So to make it pure we need to undergo a process of refining. So that is actually called the refining of metal. The refining of metal is done through various methods. We will learn these 6 methods today, how in different methods the refining is done based on the nature of the metal and the impurities present in the impure metal. Okay, so the first thing we are going to discuss is actually what is refining. So refining is a process in which we are going to purify the impure metal that is obtained after the reduction of the ore. Now various methods will be available there to purify the metal. The different methods are the distillation method, the liquefaction method, chromatographic method, electrolysis, zone refining and vapor phase refining. Now the choice of purification method actually depends upon the nature of the metal and also the nature of the impurities present in the metal. So the first process which we will go through is distillation. So distillation, this is the process which is useful for the metals like zinc and mercury, as it has very low boiling point. The impure metal is evaporated to obtain the pure metal as the distillate. So this is through a simple process of distillation we can purify our impure zinc or mercury. The next is liquefaction. In this method a low melting metal like tin can be made to flow on a sloping surface. So this is appropriate for the impure tin, that means metals like tin which has a very low melting point. Okay, and the impure metal is allowed to flow on a sloping surface, and in this way we can separate it from the impurities which have the high melting point compared to the particular metal like tin. Then the next step is electrolytic refining. So electrolytic refining means the refining is done through the process of electrolysis. Okay, so since it is done through the process of electrolysis, there should be a cathode, there should be an anode, and there should be an electrolyte. Now here, suppose if we want to do the electrolytic refining for copper, especially for copper and zinc, we can use for go for electrolytic refining process. So here what we will do, we will take impure copper as the anode and pure copper as the cathode. And the electrolyte we can take any of the salt of the copper. Okay. So here what will happen, the more basic metal will remain in the solution and the less basic metals or the less basic ones, they will go to form the anode mass, and the reactions will take place at the respective anode and cathode. So here the oxidation and the reduction will be taking place at anode and cathode respectively. Okay. So the next one you see, this is zone refining. Zone refining is a very important process of refining, and in board the questions are always asked based on the principle of zone refining. So you see, this method is based on the principle that the impurities are more soluble in the molten form as compared to the solid state of the metal. That means the metal has to be converted to the molten form so that the impurities becomes more soluble than compared to the solid state of the metal. So what it is done, a circular mobile heater is fixed at one end of the rod of the impure metal. The molten zone moves along the heater which is moved forward. As the heater moves forward, the pure metal, it will crystallize out of the melt and the impurities pass into the adjacent molten zone. The process is repeated several times and the heater is moved in the same direction. So at one time what will happen, the impurities get concentrated. So this end is cut off, and this method is useful for producing semiconductor and other metals of very high impurity like germanium, silicon, boron, gallium and indium. So the main principle behind zone refining is that the impurities are more soluble in the molten state as compared to the solid state of the metal. So this is the principle behind the zone refining. Okay. Then next we'll move towards vapor phase refining. you can see here vapor phase refining. So vapor phase refining, here you see it is a refining method in which the metal is converted into a volatile compound and is collected elsewhere. It is then decomposed to give the pure metal. For example, there are two processes which are discussed here. One is Mond's process and another one is Nickel's process. The first part of the equation is nickel. It is treated with carbon monoxide to form a volatile compound, that is nickel tetracarbonyl. Okay, and after some time, what happens when this is obtained? The nickel tetracarbonyl is again further decomposed to give you nickel and carbon monoxide back. So this is Mond's process of refining. The next one is another process which is known as Van Arkel method. So metal is converted by heating with a little amount of iodine to a volatile compound, that is the metallic tetraiodide will be formed and is then decomposed by electrically heating above 1800 Kelvin with tungsten filament to pure metal, which is then deposited in the tungsten filament. So the reactions are given here. You see there is a little problem with the arrow here, just understand it. First is titanium with iodine, you will get TiI4, that is your tetraiodide titanium. Then this tetraiodide titanium is again heated at 800 Kelvin to give you titanium back along with iodine. So in the vapor phase refining process, we will come across Mond's process as well as Van Arkel's process. So Mond's process generally we go for nickel, and Van Arkel's process we go for titanium and zirconium. Then you see this electrolytic refining is shown in a very nice way. You can take the note from this slide also. The picture is given and the electrolytic refining is also explained here. Okay, so you can make a note from this part of the slide. Then we will move to another one, that is chromatographic method. So chromatography is a technique of purification actually. So this is a technique which you have already learned in class 11. There you have learned about three types of chromatography, that is paper chromatography, gas chromatography and column chromatography. Okay. Now this is also based on the principle. And what is the principle? In this process, the impure metal is put in a medium. The medium may be a liquid or a gas. Then we move the medium through an adsorbent. That means the medium is moved through an adsorbent. Different components of the impure metal will be absorbed at the different levels. And then the components that were absorbed are removed by using a suitable solvent. So column chromatography is used for the separation and purification. Okay. In paper chromatography, you have seen that how we used to separate the dyes, the different colors. Suppose if your dye is black, it is a composition of two or different color of dyes, and how we separate the dyes in a paper chromatography. Actually, we see that the dyes are soluble in the solvent, that is called eluent in chromatography, and we will see the way that will be absorbed by the chromatographic paper will be different for both the dyes. And that is the way how they are going to separate out from a single colored ink. So this chromatographic method will also used as a purification technique. Then we come across uses of zinc, aluminium, copper and iron. So zinc is used in alloys such as brass, nickel, silver and aluminium solder. Zinc oxide is widely used in the manufacture of many products such as paints, rubber, cosmetics, pharmaceuticals, plastics, ink, soaps, batteries, textiles and electrical equipment. Aluminium trim, rails, sliding are a great choice of corrosion resistant and attractive appearance of any building. Okay. So here you will see aluminium bar has many different applications in the medical assembly, aircraft construction, structural components and commercial transportation. Copper is used in the electrical equipment such as wiring and motors. This is because it conducts both heat and electricity very well and can be drawn into wires. It also has uses in construction and industrial machinery. Then it is used, this is for iron, it is used in the manufacture of steel and is also used in civil engineering like reinforced concrete, girders, etc. Iron is used to make alloys like carbon steels with additives such as nickel, chromium, vanadium, tungsten and manganese. So these are the uses of some of the metals which we have discussed in this chapter. So my dear students, please go through the different techniques which is used for refining of the impure metal, and especially the principle involved in each of the technique is very important for your exam. Okay, and sometimes you are asked for 1 mark question that name a metal which is involved or which can be used in this refining technique. Okay, or this kind of questions you may get for MCQ for 1 mark question also. So prepare your note accordingly, and please send it to me on Wednesday. That's all for today. Thank you. Have a great day ahead.